Okay, so thanks everybody for joining me. Very short notice tonight. We're going to talk about different flavours of internet-based VPNs. So that's what can largely be described as Ipsec Vpn or Ssl Vpn. But there's lots of different flavours, there's lots of different deployment topologies. So we'll not be able to cover every single scenario that's possible, but we'll be able to cover a good part of it. So I'll give an overview of the technologies that are available, and then some of the use cases and things like that, and then we can just move into like an open discussion. Any questions that you've got throughout, just put them in the chat and I'll try to keep on top of it. Hopefully I'm a bit better prepared in the second stream or my second Twitch stream, and we'll be able to deal with it as we go through. So just checking that you can all see the VPN overview slide here, which is I think there's a little bit of lag on the feed, but all good. You should be able to see a VPN overview. I'll assume that you can. So what we're going to do is we'll just talk about some of I always like to set the scene as to why we would need an internet-based VPN. So first of all, what is an internet-based VPN? And in simple terms, it's a mechanism that provides users or groups of users or sites a mechanism to connect into a corporate network, either as a user, as if you were just sitting in the network, so you can access the applications, the shared drives, various different things, as if you were sitting in an office. So I'm sure everybody knows all about that at the moment in sort of April 2020 with the things that are going on in the world. So pretty much everybody in the world is probably using VPN technology, and that's why I felt that this might be a beneficial session. So you see lots of things in social media talking about this company's let everybody work from home, and they've enabled everybody to work from home, and there's multiple different ways to achieve that. So I want to cover some of them, and not all of them, but some of them on this. And it might give a bit of an indication as to how that might have been achieved, and different organisations will achieve it in different ways. So there's three sort of main reasons, and some of these will tick the boxes in regards to what's been happening in the world with the global pandemic of COVID-19. Where we just like basically work through these. It gives remote access to the network, as we already described. It gives quick access, oops, that's a big tick, and it also gives cheap access. When I say cheap access and quick access, typically if you were to deploy an internet-based circuit rather than with Ipsec VPN, whether it's remote access or site-to-site, it's a lot faster and a lot cheaper to deploy that type of solution than it is, for example, an MPLS Ethernet leased line point-to-point Metro Ethernet circuit or something like that. And the reality of it is that you're never really going to have a leased line or remote access, a leased line or a Ethernet circuit directly into the corporate network from someone's house, unless you're maybe like the CEO of the company or something like that. So it's basically, it provides an overlay, a secure overlay on the top of the internet, which is a secure tunnel, whether it's from your client PC or your router or firewall at your site into somewhere within the corporate network. So that pretty much sums up why we would use an internet-based VPN. The types of VPN vary greatly. So we've got a few different options here, including remote access VPN client. So that would be something like Cisco AnyConnect or Palo Alto, can't remember the exact product name, the Protect or the Checkpoint client or something like that, which is physically installed on your PC as a program. The other remote access VPN, and when we say remote access VPN, you'll sometimes see this abbreviated in design documentation to Are Ssl Vpn, and sometimes the author of the document won't, well, they might have a table of acronyms, but they might also make an assumption that whoever's reading the document knows what that means. But when you see that acronym in a design document, that's probably, well, that is what it means. It's remote access VPN, and you associate that with client-based or single user VPN. So that, and again, that's client software, so it would be something like Cisco just use Cisco AnyConnect because it's pretty common. You would have a little icon in your system tray, and it can be configured in multiple different ways. But it can be configured to automatically connect. Typically, these clients or with user input. So the fact that you need a client on the machine and user input is sometimes why, depending on the type of access or what you've got in the back end systems in the data center, which we'll talk about in a minute, relates to SSL VPN, that might drive you towards having a VPN client. And I guess it could also be categorized as a thick client. So you've got software on your machine. You use that software on the machine to connect into the environment, and once you're connected, it's completely as if you're sitting on the network. So it's almost like transparent to being in the office. It's the same. Remote access VPN via an SSL client is slightly different, and that's normally still referred to as remote access VPN, but it's specifically mentioned as SSL VPN. And what that basically means is if you've got services here that you want to access services, right? And then you basically, well, that's actually a bad example. I'm going to draw this out later on. But what SSL VPN allows you to do is, let's say you connect into the corporate firewall. So you come from the remote location, and what you actually do, instead of having a client installed on your PC, you would maybe go to sslvpn.companyname.com, and then you would authenticate by putting your username into a username form or field in a browser, and then you would authenticate with a password. More often than not, that's done using like a secure token. So you might have like an app on your phone that gives you like a 6-digit code or something like that, and you type in your username, which is normally your corporate Active Directory or whatever username, plus your token. Once you then get into there's a couple of different ways that you can set this up after you authenticate. So you can either set it up where you then enter into like a portal page, right? So you basically authenticate through the firewall, and then you land in a portal page, and that might have 5 or 6 or one. It might have one application, so it might have an icon for a remote desktop session. So if you want full access to the network via a SSL VPN, an SSL VPN is more used to present specific applications to the user, rather than give you like full-blown access. If you wanted full-blown access via an SSL VPN, it's normally you authenticate through a web browser, and then you might have a remote desktop or VDI session into a back-end Citrix farm or something like that, or a specific server. Or you can set it up once you authenticate through the SSL VPN. You might only have access to a single application, so it might be Outlook or a CRM system or the intranet or something like that. And the benefits of SSL VPN is that it uses TLS typically, which is the authentication within web browsers. Authentication within the web browser, and it doesn't need a client, so there's less issues with if you've got lots of different users with lots of different types of machine, for example. You don't have to worry about that compatibility issue of the client being installed on the machine and things like that. So that's a high level overview of SSL VPN. We then have Ipsec VPN Static. Let's see if this works. Oh, there we go. Ipsec VPN Static. And what I mean by this is you have a site router at one side, and or it might be a firewall, and then another location, and you set up an Ipsec VPN tunnel between this interface and this interface, and you say, I want to peer a secure tunnel from here to here, and you effectively nail that up. So from a design perspective, if you then if you then think that's okay, and this is how, again, maybe 10 years ago when I first started getting into like Ipsec VPNs, that's how sites typically connected into the network if they used Ipsec VPN. So I'll just draw it in green, but these are the Ipsec tunnels, right? So if you had an Ipsec, or if you have an Ipsec based WAN, the traffic flow is as you see. I'll draw it in a different color actually. So if I'll draw it in purple. So if this site wants to talk to this site, then they need to communicate via the hub like this, and that's obviously inefficient. I mean, it does the job if you have to use it, and there might be reasons why you want to use it. For example, if they're like back in the day, the main reasons for that and wanting that type of topology was when a company would say, we want all traffic that goes between HQ sites when they're on an Ipsec VPN to come via the head office, because we want them to go through a central policy server or something like that. So it's more of like a compliance and a security thing. So that's Ipsec VPN static, and it's basically traditional as you would know Ipsec VPN. Now, if we've then got Ipsec VPN Dynamic, this is where you start talking about things like the most common one probably is like Cisco DM VPN, so Dynamic Multi-Point VPN. And how this works is if you've got a site here, I'll just draw 3 sites in the equation, right? If you've got 3 sites that need to, like this is the HQ up here, or the data center, whatever. And if this site, if I change the color, if this site needs to talk to this site, how this communication works, and this is basically paved the way for SD-WAN. So although when you see people talking about SD-WAN as if it's, there's a lot of things to the SD-WAN which are different and good and better than what we've had in the past, but it's all based on technology I guess, like DMVPN, and I know other vendors have got, like Juniper have got an equivalent, and I'm pretty sure other vendors do as well. But what happens in this scenario, right, is if we say, oops, don't know what happened there. If we say, yeah, I don't know what happened there. Just look at this interface that I'm drawing, right? If we have these three interfaces, these are the WAN interfaces. They might be loop back interfaces or whatever, right? And we have a transport. So forget about what transport type it is. It's a WAN, right? And all of these sites are connected to the WAN. So it could be the internet, it could be an MPLS network or whatever. So what happens in this particular scenario of automatic VPNs is that this site basically has to talk to something central all the time, and so does this one. And every site, so they still have this hub and spoke communication, right? However, that's at the control plane. So if without going into the deep level explanation of different things, the control plane is in a networking device is where you run all of your protocol information and signaling information. So, for example, control plane signaling would be like routing protocols and things like that. But the data plane is where the traffic actually passes, right? So the control plane, if you think in this scenario, right, like this guy in the HQ, and if you think about it, this is like the equivalent to whatever the central SD-WAN box is, or orchestration, or SD-WAN controller, right? And what that basically says, if we say this is site 1 and this is site 2, what happens is this yellow site 1 says to the HQ, I want to talk to make a call or something like that to a subnet on site 2. So that request goes up via the control plane, and it says, how do I get to site 2? And then from all over the control plane, so the routing protocol like BGP, OSPF, or proprietary protocol, whatever, says, in order to get to site 2, what you need to do is talk to this interface. I don't know, let's just say this is x.x. Terrible, I'm annotating with a mouse, so sorry about that. x.54. So this address is available in the underlay of the environment. So what happens is, so in the blue environment, so what happens is over let me just change the color to, I'll recap this in a second, right? Let's use the purple again. So what happens here is from site 1 to site 2, it then builds the tunnel direct between the sites. And that's a very high level, pie in the sky explanation as to how dynamic VPN works. So instead of this scenario over here, where you've not really got that much intelligence, because it's a manual process that you're telling the end sites or the edge sites, in order for, let's say that's 1 and that's 2, in order for 1 to talk to 2, you have to go via the HQ, which is tromboning traffic, adding latency, could potentially impact performance and things like that. But what we're doing in a dynamic VPN environment is we still have that traffic flow. We still have that traffic flow, but for a different reason. Hopefully this laser pointer works. So we have the traffic flow where we're querying the HQ. Site 1 is querying the HQ to say, how do I get to site 2? And once the HQ then tells site 1 how to get to site 2, i.e. via this WAN interface, it says, this is how you get to site 2, and this guy basically says, alright, now I know how to get to site 2, so I'll build a tunnel automatically to site 2 in order to transfer the traffic. And that dynamic tunnel usually stays up for an amount of time until the session either times out or there's no traffic being sent over the tunnel anymore. So that's how dynamic Ipsec VPN and yeah, we could go into a lot of detail as to it might not always be encrypted. So it might not be an Ipsec VPN, it might be multi-point GRE, but yeah, we don't really want to go into that because we've not got enough time in this session. But typically if we're talking about internet based, it's going to be encrypted. So I'm going to pause there to see if there's any questions whilst I'm clearing the annotation, and just put them in the chat if you've got any questions about that whilst I figure out how to clear this. And I've actually covered some of the stuff in the next slide, to be honest, but we'll go with it in a diagram and try and do a bit of drawing in a second, and I'll just pull that diagram up anyway. But before actually I do that, what I want to do is talk about something else. So hopefully you can see another diagram on the screen now, which looks very complicated. But I want to explain this because this is pretty much what networks are going to look like in the future. And the reason that I want to explain this is because it shows multiple clouds, and actually I'll talk through it and I'll explain what we've actually got. So what I was actually trying to explain in this diagram on the screen, I might not be able to annotate very much over the top of it. I'll just do it in red. But what we have here is basically all the devices that you see all around the place. Wow, that's a thick line. These are all different traffic flows, which might be WAN traffic over an MPLS network, for example. But just because it's over an MPLS network, a lot of people think that MPLS networks are private. But what you've got to remember is that, let's say that this transport here is an MPLS network, which is shown in the diagram. Now, even 5 years ago, maybe not in banks and things like that, people just assumed because you were getting an MPLS network from a provider that it was private. But the reality of it is that MPLS networks are shared between multiple customers. It would take some really bad mistake or misconfiguration in order to for different customers' traffic to get mixed up or whatever. But at the end of the day, they're not private. So one of the things that some customers might do is they might put a device that's capable of something like DMVPN on the network in behind where the MPLS network terminates, or if they manage the circuit or if they manage the CPE, so this device at the site themselves, they might make sure that is capable of doing an overlay like DMVPN or even Ipsec VPN. But you also see in this diagram that you also have multiple different traffic flows. So you might have Ipsec VPN up to the cloud, to like one Ipsec VPN might be going to AWS or DMVPN or I can't remember, ADVPN or whatever it is in Juniper. And then the other thing that we're actually seeing in the industry is that we've got client software going on like IoT field devices that have VPNs over LTE networks directly into the cloud, like AWS and things like that. So it might or might not terminate on like a VPN concentrator that sits in the cloud, or it might come. Let me see if I can delete that line. So the other traffic flow that it might have is it might, let's say this IoT field device, does it really make sense to come over the internet like that and terminate on this firewall and then route back out up to the cloud? Probably not. So that's what we're seeing now, and by this device here having a direct internet access, so that might be an iPad, it might be a tablet, whatever. By that having access directly onto the internet, and if it goes instead of this way, it actually goes this way directly into the cloud, then that means that the entry point of your network has now potentially moved to this device. So if I'm a bad guy hacker, even though pink isn't a very hacker-esque colour, but well, maybe it is. They're disguising themselves. They're not a friendly pink person. They're actually a hacker disguising as a friendly pink person, and they come in via the internet, and then they hack this device, and then this is actually connected to the Wi-Fi as well. Let's see, for another that says AP, wireless AP, then they could potentially have like backdoors into the network. So I mean, if your VPN client is configured properly and your device is hardened and all that, then there's a very small chance of that actually happening, to be honest. But you never know. Misconfigurations and IoT devices. A lot of IoT devices are dumb, and they might have like VPN clients built into them. So yeah. So if it's there's not much more to say on that, to be honest. So hopefully that explains a bit more about that scenario. And the key point in this diagram that I want to put across is that traffic flows are getting so complicated in the network, even if you just look at it from a routing perspective and avoiding routing loops and things like that. So if we move on a little bit then, so we've got IoT field devices, we've got IoT VPN devices, and then the traditional stuff that we were talking about earlier. Like, so up here you've got like your PCs with your IPsec client, and the traffic flow that they would come in. So let's say there was like an application here. This machine up the top would IPsec into either this firewall down here or something. It might be a dedicated firewall for VPN. down here. And once it's like VPN'd in there, then you've got access into you know, the applications at the back end of the infrastructure. So now, let's have a think about this then, and let me just refresh my memory, because a lot of this is off the cuff. So what have we covered? We've covered a bit of background about remote access. We've covered the types of VPN. So just to kind of recap on that, in the diagram, let me clear all the ink. Erase all ink. So if we recap on the four different types of VPN, the IPsec remote sites are indicated up here. So that could be sites or users. Absolutely terrible drawing. And they would typically come in via to the data center and authenticate against, you know, either the internet facing firewall or something off to the side. So it could be a dedicated VPN appliance, you know, that sits off here. Why would it be dedicated? It would potentially be dedicated if, for example, this thing was only to do inbound, outbound internet access, and let's say that in most firewall platforms, the more services that you add onto it, the more impacted the CPU and things like that, and the hardware resources are. So you might want, like, if you've got a large environment like 500 users, 1,000 users, 5,000 users that all use VPN, you might want either something off to the side, or you might have another data center up here with a VPN appliance connected into the internet, and you might have some traffic that goes this way and some traffic that goes this way. So that's the remote access, and then the IPsec, again, it would follow for the point the static IPsec, so the hub and spoke. You might have another site here which basically follows the same path, and then for site 1 to talk to site 2, it would basically need to follow this traffic flow in here as you see it at the moment in order to talk to each other. And the same traffic flow would happen for remote access VPN users. So that covers off. If we then move into like the DM VPN example, so the traffic, basically the traffic flow for the control plane would go from that blue interface, and it would talk to, you know, a blue device in here, right? And that would say, in order for site 1, if we change this to blue now, to talk to site 2, you need to build a DM, like a dynamic tunnel between the two sites. So the red traffic flow that you see going into the data center will always be there, but that will only be there in order to tell site 1, in order to speak to site 2, you need to go to like this IP address and build a dynamic tunnel. So going back to the presentation, just see what else. SSL VPN, from a traffic flow perspective, it would be the red line coming into the data center, and you would authenticate, you would go to your browser, and let me see if I can I'll try and differentiate it a little bit. Let's say it's green. You might come into this device again, right? But there might be a very specific application that you need. and it might only be site 2 that's allowed to access that. So if you look at it from an SSL VPN perspective, the red traffic flow would represent, you know, I guess the equivalent to the control plane in DMVPN. So that gets you to the device that is capable of presenting the application to you. You then authenticate to it, and once you're authenticated to it, normally via two-factor authentication, you can then actually communicate with the application, which is the traffic flow like that. So that covers SSL VPN, and I think that's us from that perspective. And then the final thing, I'll just maybe clear some of this out. It disappears. Yeah, just clear some of this out. So from a third party VP, let's draw another colour. We're running out of colours here, but we'll get by. So if I was a third party, say I was like a service provider or an application provider, and I was supporting your application, then, you know, my site would be down here somewhere connected to the internet. And basically I would come in via the internet, and there's the two most typical ways that I see SSL VPN, is that I see third-party VPNs configured at the moment, is either to have an SSL VPN, so that would actually be the green traffic flow, so but with a blue line. So let's say if you had another resource here, that the blue site managed as part of a managed service, then they would come into, you know, the same sort of SSL VPN firewall, whether it was there or it might be a dedicated third party firewall, and then that would give them access only to that application. So it might be via a web browser, or it might be an RDP session or something like that. So once they've authenticated via the blue line, this you know, they might have like a client workstation on their LAN, which is like a client workstation here, which is the only workstation that's allowed to communicate with this service up here in the bottom left. The other option is that this blue line that I've drawn from the site router to the firewall, that could just be like a static IPsec tunnel over the internet, and that's pretty common as well. That's more for if like you were an internet service provider and you were managing like all routers or all switches or all firewalls on the network, you would come in via an Ipsec VPN, normally via a dedicated third party connection and firewall, or end up in like a sort of air gapped DMZ where you're not able to access anything else on the network, and you land in there and then manage the network from that point of entry. So I'll just go back to the presentation. So I think that pretty much covers most of the considerations on Ipsec VPN design. Some of the things that just moving away from actually the technical operations, some of the things that you need to think about if you're a network designer, whether it depends. So if you're a solution architect, the types of things that you would need to worry about or think about are where about are the data centers. So you might have this data center down here, but you might also have a data center up here. In the top left. And then you might actually have a data center in another global region. So the VPN design can get quite complicated. If this is, let's say this is EMEA, so Europe, this is North America, and this is LATAM, Latin America, and then let's say you've got another down in the bottom right, which is APAC or Asia Pacific. And if you've got global presence, then you need to make sure that you're configuring or designing your VPN so that your users in each region use the VPN within their region. So for example, if you've got a user out at APAC here, you don't really want, if this is your user, however, this is a terrible representation of a user, but you don't want like in APAC authenticating to North America. You want them authenticating here in APAC, so into the APAC data center. And there's lots of different ways that you can configure that and things. So, but it's a consideration. So, where you terminate, and then actually another thing which is just for consideration, right? You might have, let's say that this data center and this one here are both in North America, and let's say, for example, this VPN device fails. It might be that you have users come in into this data center instead, or it might be that you only have IT staff come into this data center, and then that's only a mechanism to get IT staff into this data center when there's a connectivity issue. For example, let's say the WAN links failed. They could come into the second data center and then over the backdoor link, but you could say that only the IT staff were able to do that, and you didn't want users to come in, and that all plays into So there's a few things. There's the different regions, how you want the different types of users to utilize the VPN, and then there's also in most platforms there's like a licensing aspect. So one of the biggest challenges that probably happened, I would imagine, during like the COVID-19 pandemic, when companies probably went from 10%, or some really large companies went from 10% of their 10% of their workforce. Yeah, no problem. Thanks for joining. 10% of their workforce maybe used VPN, and they had only bought that amount of licenses. So if there was 10,000 users, they might have only bought 1,000 VPN licenses, because normally people even if they had a laptop, maybe went into the office every day, and they never worked from home. So so those are the types of things, where you're going to connect, how many licenses you're going to need, the traffic flows, even with the VPN. Do you go hub and spoke, or do you go dynamic VPN? So there's quite a few different ways of delivering. And the final thing that I'll not really go into detail is that, one of the things we never even talked about is there's actually devices as well that you may or may not be aware of. I don't know if I'll be able to draw it out, but where this Ipsec VPN is at the top right. So these Ipsec remote sites and cloud access routers. This might actually be someone's house, and what we also see is that, for example, Meraki have something like a teleworker device where you connect a Meraki teleworker access point with an Ethernet port into your broadband or your home router, and what that allows you to do is automatically connect to your corporate network without doing anything. It's pre-staged before it's sent out to the person, and it creates like a VPN tunnel, say back to the data center or the HQ, and it then broadcasts the corporate SSID. So that's another way of delivering on a VPN, but it doesn't really have any user impact. They're given something, so that's more like for something that execs would get given, or IT staff, so that they can basically get the corporate SSID, and in that case the client doesn't even know that it's on a VPN. It's like having a site-to-site VPN, but it's dynamic, and that's probably the last solution that I can think of off the top of my head. So hopefully that we're going to round up there, because it's getting on a little bit. We've covered quite a lot. In summary, it's just really to illustrate the fact that when people say, "Oh yeah, I'm working from home," it's not always as easy as people think. So there's a whole load of different design aspects that we need to look at here, and yeah, so that's it really. Hopefully you enjoyed this session. Again, thanks for joining me on your Saturday, and at very short notice. I hope you learned something, or and you found it interesting, and I wish you a pleasant rest of your day, and happy Easter tomorrow when it comes. Thank you very much. The YouTube video will be on in the next day or so. Take care. Bye.